This is one of the wonderful pages from Algeria's glorious history. This invention is not widely known within the public, and it's called the Algiers problem, or the Algiers mathematical issue. It also has other names that we will discuss later on. If we ask the people of mathematics who was the first to introduce the logarithm, the answer you will get is that the logarithm was introduced by John Napier in 1614. I will show you throughout this video that the logarithm was instead introduced by an Algerian mathematician named Ali ibn Hamza, known also as Ibn Hamza al-Maghribi and also Ibn Hamza al-Jazairi. Let's go over his story together. In 1913, a Turkish scientist named Salah Zeki was doing research and reading through the Ottoman archives related to science and mathematics and found a book titled تحفة الأعداد لذوي الرشد والسداد, which means the gift of numbers for the possessors of reason and correct insight. This book was written in 1590, which was way before the introduction of the logarithm by John Napier in 1614. Strangely, the book explained the logarithm and suggested it as a calculus way to solve many mathematical problems. The Turkish scientist Salah Zeki then wrote a book in the Turkish language introducing Ali ibn Hamza al-Maghribi to the world. Let's read some quotes related to Ibn Hamza. In this book, he is Ali bin Wali ibn Hamza from the western side of the Arab world known as the Al-Maghrib, living in Mecca. He authored a book, The Gift of Numbers for the Possessors of Reason and Correct Insight in Algebra, and his name was mentioned in one of the old manuscripts in London. In this book, Ibn Hamza al-Maghribi, who authored books in Turkish language and helped in making it a scientific language, his work in mathematic fields was the first of its kind from the 16th to the 18th century. His full name is Ali bin Wali ibn Hamza al-Maghribi, and he was born in Algeria. He moved at some point to Istanbul, returned on 1586 to Algeria, then moved to Mecca on 1591. He was very creative in finding mathematical solutions in derivations and fractions. He could easily find square roots for integers and irrational numbers and find square roots up to the power of 3 or 4, and he also introduced the sequences. And here we read, in regards to the logarithm, it was introduced by Ibn Hamza 24 years before Napier had published his work on it. Here, a list of his works and books, and the museum where his manuscripts are located. Here, we read that the Library of Istanbul contains the original version of Ibn Hamza's book mentioned above, The Gift of Numbers. And here, Ibn Hamza is from Algiers city, and one of his manuscripts is located in the Cairo Museum in Egypt. The subject of the book needs thorough studies. Lastly, we read in this book a discussion between someone from India and Ibn Hamza. We will talk about this discussion next. Ibn Hamza confirms through the discussion that he speaks Arabic and Turkish, as his father is Algerian and his mother is Turkish. And in regards to the Algiers problem, which is also called the Meccan problem or the Indian problem, it's related to a riddle or a puzzle originated in India, and it says, a man left 9 children and 81 palm trees. The first one produces 1 pound of dates in 1 year, the second one produces 2 pounds, and the third one produces 3 pounds, and so on, until the last one, which produces 81 pounds of dates in a year. The ask is to divide the trees between his kids so their share will be equal in terms of numbers of trees and in terms of benefits from dates, which means that everyone shall have 9 trees that will produce an exact number of pounds of dates in a year, and this should be true for all 9 children. The children didn't know how to apply this division between them according to their father's will, so they took their problem to the Indian mathematicians, and they weren't able to find a convincing solution for them, nor were they able to find a rule to follow towards solving this problem. One of the Indian pilgrims knew that the mathematician Ibn Hamza was in Mecca, so he went to him with his problem. Ibn Hamza told him every child shall produce 369 pounds of dates in a year. He drew a table for him and put a column for each child, and he started to distribute the trees among them. The first tree to the first child, till the 9th tree to the 9th child, but for the 10th tree, he jumped and assigned it to the second child instead of the first. He continued with the 11th, the 12th, till the 17th tree, then he assigned the 18th to the first. And so for each row, he was shifting one line to the left until the palm tree number 81 that was assigned to the 9th child. And the result was quite dazzling, as it was the first time a solution was given, so every child would receive an equal amount of dates. This is how Ibn Hamza, a man way ahead of his time, was able to solve the problem. I hope this video is an addition to your historic knowledge.